So there are two main goals in algebra. The first one is to analyze functions, and the second one is to manipulate math sentences. I used to say that this was to maintain equalities, but then that would exclude the fact that we work with inequalities all the time. In order to understand how to work with these, we first need to know what numbers we're even working with. So what I want you to do right now is to go get a piece of paper, get some markers, some colored pencils, or if you're boring, you can just use a pen, but I'm going to use a bunch of different colors because we're going to draw a picture together entitled The Sets of Numbers. Now, what is a set? A set is just a collection of objects, a group. And it's going to kind of resemble a Venn diagram, almost. Here, you'll see what I'm trying to say. First set in question is the natural numbers. And the natural numbers are just like the counting numbers. Like when you learned what numbers were in even kindergarten or whatever, you would go 1, 2, 3, 4. These are the counting numbers. These are the natural numbers. Oh, and if you are either German or know American Sign Language, it's 1, 2, 3, 4, like that. Anyway, so I'm going to write some examples for each of these sets, and you can use whatever examples you want, not necessarily the ones I'm going to put. So 1 works, 42, 7, 4,830. These are all natural numbers. And there's infinitely many of these, so you can't write them all down. Now, some people will say that 0 is not a natural number because you don't start counting as 0, 1, 2. I like to include it in, so you can kind of put a 0 here, maybe with a question mark attached to it. Because the next set of numbers then would be all of the natural numbers plus 0, and those are called the whole numbers. But I don't know, I feel like that's kind of a waste of space, and we can just kind of put 0 in here and just kind of know that it's 0. Furthermore, with 0, it's neither a positive nor a negative number. Even though we don't put like a plus in front of the positive numbers, 0 is not positive. It doesn't have any value to it. Speaking of negative numbers, I'm going to go to this blue color here. And we're going to draw a circle, oval, ellipse type shape around and completely enclosing the natural numbers here. And we have the integers. The reason why we're enclosing in on the natural numbers is because each natural number is also an integer. And an integer is just a non-decimal, non-fraction, an entire whole number that are also negatives. So we have -2, -67, -42,000. Yeah, whatever numbers you want to put in on this. The next all-inclusive set here, again, we're going to wrap all the way around the integers. These are called the rational numbers. Now, if I were to take the word rational and kind of remove a few letters, you see the word ratio there. That's not a coincidence. Ratio is a comparison, a relationship between two numbers, and that's what the rational numbers do. Rational numbers are anything that can be represented as a fraction, and we know what fractions are. So we can have 3/4, we can have -1/12. We can have the negative numbers because then the integers couldn't be inside the rational numbers like this. Just so we're clear, the integers and the natural numbers are inside the rational numbers bubble there. So that would imply that the integers and natural numbers are also fractions. But, 42, -67, they don't look very fractiony. But we can take any of those inner numbers and make them into a fraction by dividing them by 1. And as we know, anything divided by 1 is itself. So this is their fraction form, but we don't ever write it like this. We just kind of clean it up. So just in case that was bothering you, yes, they are technically fractions. We can also have improper fractions. So like 5/2 works. So we can write any fraction as a decimal. And specifically, decimals that are terminating or repeating. An example of a terminating decimal would be something like 1/2, which is the same thing as 0.5. See how it ends? There's nothing else after that. That means that it's terminating. A repeating decimal is something like 1/3, which, if you know this, it's the same thing as putting 0.3, 3, 3, and so on forever. Infinitely many 3s afterwards. A more concise way to write that, you may have seen this before, is 3 with a little bar over the top, the repeating bar or the repetend. And that literally means this. That means that whatever is under the bar here, that is what is repeated on forever. I'll give you another example of something that's repeating. So we have 1/7, which is the same thing as 0.14. Make that look a little better. 14285 and the bar is over the entire chunk there. So if I were to want to expand this out a little bit further, it'd be 0.142857, 1428571, and like that. So any terminating or repeating decimal can be in the form of a fraction. But what about non-terminating, non-repeating decimals?